Time is a thing which everybody speaks of, but no one has seen.
Time is a human construct. It is a measurement of our perception of reality, a complex network of events onto which we project sequences of past, present, and future.
1 minute corresponds to 60 seconds, an hour corresponds to 60 minutes, and a day corresponds to 24 hours. We schedule our days according to time, our watches and calendars. We live our lives as the seasons pass on by, while the clock is constantly ticking forwards and never backwards.
We live without the river of time. Events and actions appear to happen in an irreversible succession over time, and we experience them relative to the present.
The moment during which you are watching this video is no longer happening. This one is. Time constantly moves forward until our present becomes our future and our past remains in our memories.
We trust that time is linear, unidirectional and absolute, that it proceeds eternally, uniformly into infinity, and that it is constantly running out. Is time the same for everyone? Can we control it?
Does even time exist, or could it be just a sort of illusion generated by the limitations of the way we perceive the universe? In other words, is time an illusion perceived as a reality?
Why does time appear to flow? What if we could stop time, or at least slow it down? Would that be even possible? Or would it be another science fiction?
This is What If, and here is how time can be slowed down.
The laws of physics are the same for all non-accelerating observers. This is why when we are watching someone driving a car, it would be moving at the same speed as the car, since his speed is relative to our position. Meanwhile, the driver would be still and stationary, since his motion matches the car motion relative to the outside world.
While Einstein's theory of relative motion could be applied to all objects in the universe, light is an exception. Its speed is independent of the motion of the observer, and it is the same regardless of the perspective or reference frame.
Believe it or not, time is not the same for everyone, and it depends on your frame reference and your speed. Well, it is not the case on Earth, since the effect on time is negligible at speeds of everyday life. But here is an example that can change your vision.
Imagine someone in a spaceship traveling at the speed of light or at a speed close to it, passing next to the Earth. In that spaceship, a person lightens a torch and directs it upwards. The trajectory of the light would be as described in that person's point of view.
Now for someone on Earth, he will see the spaceship and the light in movement. Therefore, the light as seen from Earth will go upwards, but also to the right following the movement of the spaceship.
As a consequence, the distance traveled by the light is greater than the initial one. Knowing that c equals d over t, and that c is constant, t must increase.
This is why the perception of how time passes can be different between two observers, depending on how much faster one is moving compared to the other. Time is not an absolute or universal notion, but rather a relative notion.
Time moves slower for a moving object compared to a stationary one. This slowing down of time and clocks due to high speed is called time dilation.
The fact that the light always has a constant speed also led Einstein to conceive a link between time and space, known as spacetime. From one hand, Newtonian space and time presumed that time and space were fixed, and that they were independent from one another, that gravity was a force acting mysteriously between two objects.
From another hand, Einstein's theory of relativity describes the geometry of space-time and revolutionized the way we think about gravitational force. It describes how space is being curved and how time is being distorted. Einstein said that space and time are not fixed but interconnected and merged together in what is known as spacetime.
In fact, gravity is not a force between massive objects, but something that emerges from space and massive objects. It is the shape of space-time changing.
A simplified way to understand spacetime is to imagine a large elastic sheet on which is placed a massive object. The more massive object deforms the elastic sheet, and the others orbit around it while also deforming the sheet. Light always has the same speed. This means that the speed of light in the presence of gravity will be the same in empty space.
However, the distance traveled by the beam of light in a gravitational field is longer than the one traveled in empty space due to the curvature of space. So, in order for the speed of light to remain constant, time must be slower.
This means that time increases proportionally with the curvature of space near the gravitational field compared to empty space to keep the speed of light constant in both reference frames. This is why time is distorted by gravity along with space.
Space and time are parts of the same entity. It is impossible to move in space without moving in time. As John Wheeler said, space-time tells matter how to move. Matter tells space-time how to curve.
Matter curves space and slows down time. Time will also flow slower if one object has a greater relativistic velocity than another.
The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form what we call a black hole.
How is that, and to what extent space-time can be distorted? Well, this is a story for another What If.